to solve another Leetcode problem. 503, next greater element 2. So if you solve the next greater element 1, so next greater element 2 would be similar. The only difference is that the array would be a circular array. So giving a circular integer array nums. So this means, let's just try this example. So this means we're gonna check it like that. So for the first number 1, the next greater element is 2, so we get a result of 2. Yeah, but what about the second number 2? We cannot find the next greater element. We can find here it is 1, and then we go back. But how can we go back? So the normal way to solve this problem is that we can enlarge the array. So we can double the array. So before it is like that, now we double the array. Now we're gonna check that. Maybe this number is 3, it can find, but it is not. Yeah, and then we're gonna find, we never find the next greater element, so we're gonna return a -1. Yeah, so what about the next one? It is 1. So for the last number, it is 1. Yeah, so normally we cannot find it, but after enlarge the number, after double the number, we can find the next greater element must be 2, so we're gonna have a 2. Yeah. And in this way we can find all the result, and 2 minus 1, 2 gonna be the final result. Yeah, so the idea is the same. We just need to enlarge the number, and after that we're gonna use the monotonic stack to solve the problem. Yeah. So while using monotonic stack, it means we're gonna enumerate all those numbers. I mean, all those numbers, it is the 2 times of nums. It is not nums. Yeah, because we need to check all those numbers to find the next greater element. Yeah. Now let's try to solve it. So first of all, we're gonna prepare n and stack. So n should be length of the nums, and the stack would be an empty array. And we're gonna enlarge the nums, so it's gonna be nums times 2. And now we want to prepare the result array. So the result array would be a -1. This means if we didn't find it, times n times, let's use times 2 times n. Yeah, I think it's gonna be the same. Let's times n and times 2. Yeah. So this means for the result, it is also the length of the result is also the length 2 times the length of nums. But for the final result, we just need to return the result to n, because we don't need to return the double length of the nums. Yeah. Now we can use the monotonic stack. So if we are calculating the next greater element, normally this is a monotonic decreasing stack. So let's try to use the template of monotonic stack. So for ix in enumerate nums, and we can check the stack. We're gonna use a while loop to check the stack. So while there's something inside of the stack and my current number is more than that, so this is why it is the next greater element. Yeah, so x is the next greater element. If my x is more than the nums stack -1, it means I've already found the next greater element, so I want to put it inside the result. But before that, I need to pop out the index from the stack. So stack.pop, I'm gonna pop out the index, and then I want to put it inside the result. So the result would be nums. So the result would be let me check. Yeah, so for the first element, for example, it is 1. The next greater element is 2. Yeah. So the result, currently we are having the index. Yeah. So it's gonna be the result j should be equal to nums I. Yeah. So this means for the index 0, result at index 0, we're gonna have the number. So nums I is number because we need to find the element, not the index. So it's gonna be nums I. And then after the while loop, we're gonna just put it inside the stack. So we're gonna put the index I inside the stack. Yeah, so this is going to be the entire code. Let me just try to run it. As you can see, it works. Now let me submit it to check if we can pass all the testing cases. Yeah, so while submitting, let's enter. As you can see, we passed all the testing cases and it's pretty fast. So now let's analyze the time complexity. As the length of the nums is 10 to the power of 4, and we just use the monotonic stack to solve the problem. So the time complexity is O(n). Although you can say two, one is for loop, another is while loop, but this is just a stack. So we are checking the stack. We just put some element inside of the stack and take it out. So the time complexity would be 2 times n. So it is O(n). Thank you for watching. See you next time.